Hello, ladies and gentlemen. I hope everyone is doing well today. Today we're taking a look at the percent yields Chemquest. So right off the rip, we start off with some information on sources of error in the real world. You may notice that I only highlighted one thing. What I highlighted tells us that reactions in the laboratory are not ideal. So all of these calculations that we've been calculating the theoretical masses that can be formed. In a lab, that's not actually what's going to happen. The theoretical mass is the mass that would be produced if you did everything perfectly. However, we're not perfect, so that means you can either have less of a substance or more of a substance. So what you guys need to think about in question 1 and 2 is in question 1, what are some sources of error that could cause us to get less than 100% of the product? The second one tells us what could you do to get a mass that's greater. Question 3. So question 3, you need to do some of the calculations, the mass-to-mass conversions that we've been working on. So we need to use these 4 steps that are found. Remember this first one that doesn't have a number next to it, this is the only one we have to do sometimes. You do need to do this step, you do need to solve the reaction first, because the reaction was not solved. It only told us that sodium was reacting with chlorine to form sodium chloride. So then you need to solve this reaction and balance it. Then you can move on to the other steps, converting the grams to moles of what's given to us, using the mole ratio to find the moles of the compound that's in question, and then converting the moles of what's in question to grams. These are the same 3 steps from the previous 2 Chemquests. Next, not question 4 yet, but we have some information on calculating the percent yield. So we use the percent yield to calculate a little bit of error that happens in our problems. We want to calculate the percentage of what actually formed based on the theoretical, which could have formed. Remember, the theoretical yield is the amount of product that we should be able to make. Very, very hard to get that number. You have to be perfect to get that number. The actual yield is the amount of product that we actually collected. So we can find the percentage of what we actually made from the theoretical using the percent yield formula. The percent yield formula is the actual yield minus the theoretical yield times 100. So they did calculate the percent yield from question 3. However, I wanted to just talk about it and show you guys and solve question 4. That way you can model 5 and 6 after what I do in 4. So in question 4, there are going to be 3 steps that I follow. The first step is going to be to identify the limiting reactant. You can identify the limiting reactant a few ways. The first way is through language. Sometimes the language will give it away and tell you what the limiting reactant is. Or you can always compare the theoretical amount of moles with the actual amount of moles to find out which one you're going to run out of first. Then, the second step we're going to be doing is using the limiting reactant to calculate the theoretical of the amount of the compound in question. This is exactly what you do in question 3 in this Chemquest. So this is question 3. Then lastly, we need to use the percent yield formula to calculate that percent yield. So these are the 3 steps I'm going to be doing and showing you how to do. So we're going to start with question 4. Question 4, we're taking the combustion of 215 grams of butane with plenty of oxygen. So from this language, we can already tell what the limiting reactant is. So this language right here tells us plenty of oxygen. That makes it seem like you're not going to run out of oxygen. You're going to have plenty. You're going to have too much. So that means oxygen is the excess reactant, which means butane must be the limiting reactant. So then it tells us that we were able to collect 295.3 grams of water. We need to know what our percent yield is. So to do this, we need to calculate the theoretical yield, how much of water could have actually been formed, and then we can calculate the percent yield. So I am going to do the work on a separate piece of paper. So the first thing we need to do is solve this balanced reaction. So to save a little bit of time, guys, if you need help balancing reactions, you can refer to the types of chemical reactions review where I go through a few problems. So this is the balanced reaction that we need to use. We know that we have 215 grams of butane. So actually I wanted to refer to the steps. We already did step 1. We identified the limiting reactant through language. So then when we go to step 2, we need to use that limiting reactant to calculate the theoretical amount of the compound in question. So what we need to do is we take our 215 grams of butane, C4H10, and we need to convert to moles. So we'll put our grams of butane on the bottom. We'll put our moles of butane on the top. So remember, when we take our masses from the periodic table, it's always the mass of 1 mole. And then the total mass of 4 carbons and 10 hydrogens is 58 grams. This gives us 3.71 moles of C4H10. Just like in question 3, after we converted from grams to moles, we are then going to use the mole ratio to find the number of moles of the compound in question. This time, the compound in question is water. It's asking us to calculate the percent yield of water. So we know that we're going to take our 3.71 moles of butane and we're going to convert to moles of water. Remember, before we can go to grams of water, we need to go to moles first. Whenever you have mole over mole, that tells us to use the balanced coefficients as the number of moles. So it tells us we have 10 moles of water, so we put a 10 next to moles of H2O. It then tells us we have 2 moles of butane, C4H10, so we put a 2 next to C4H10. When we solve this and type it in our calculator, we find that the answer is 18.55 moles of water. We can then move on to the last step, which is converting our moles to grams. So we will take our 18.55 moles of water, and now we need to convert to grams of water. So that means we'll put our moles on the bottom so they cancel. We'll put our grams of water on the top so we convert to it. We then, remember, when we take our masses from the periodic table, it's always of 1 mole. The mass of 2 hydrogens plus 1 oxygen is 18. Once we multiply, we find that there is 333.9 grams of water could be produced. Remember, this number right here that we just calculated, this is the theoretical amounts. This is the amount that you could get if you were perfect. That means that the number inside of the problem, this is the actual amount. This is how much you were actually able to collect. So that means when we go and use our percent yield formula, when we're solving the percent yield equals the actual yield over the theoretical yield times 100, we'll know what numbers to plug in. So I can't really show the problem anymore because I'm too far down on this piece of paper. Actually, I can fold the paper. So we know that our actual yield was 295.3. So that means we'll put 295.3 in the numerator. Our theoretical yield, what we just calculated, was 333.9. So we will put that in the denominator, and then it's all multiplied by 100. Once you solve this, you find that you were able to collect 88.44% of the water that was possible to collect. So guys, I would like you guys to work on questions 5 and 6. Remember, just like in question 4, the reactions weren't solved for you, so you do need to write down what was reacted and then solve and balance it. Remember, after you solve and balance the reaction, the 3 steps that you need to do are listed right here. The first step is to identify the limiting reactant, either through language or comparing the theoretical amount of moles with the actual amount of moles. The second step is to then use the limiting reactant to calculate the theoretical amount of the compound in question, similarly to what you did in question 3. And then lastly, we use the percent yield formula to calculate the percent yield. So like always, guys, if you have questions, write down what your question is. Try to do every step until you get stuck, and then tell me what step you got stuck on so I know how to help you. If, like always, I'll see you guys in class. I hope everyone has a wonderful day. Bye.